What's happened? Bro, it's my first stream. Does it? Is it working? Are we live? Hello? Oh my god, are we live? What's happened? Yeah, we're live. Bro, it's my first stream. Does it? Is it working? Are we live? Let me. Oh my god. Yeah, we're live. Nice, it's working, I guess. Let's see how bad my quality of my stream is after this. Let me. Oh my god. It's probably gonna look weird, but I don't know. I hope my quality of my stream is good. How good is it? God knows. It's probably like some crappy video. It's probably very funny. Yeah, but what are we going to learn today? I don't know. Well, I thought we were gonna do some databases things because I need to study that subject, so we can do programming. I think I need to do databases. Well, it is everywhere. You can just basic, give me. Oh my god. Okay, so we need to do the transaction management. And we need to look at the slides material here. Oh, it's a PowerPoint. Okay, let's see what happens when I open the PowerPoint. It just downloads it. Doesn't it? Like, it just downloads the file. Nice. Downloads. Yes. Oh my god. Where is the focus of this here, camera? Hello? Hello, this is me. Oh my god. Where did the PowerPoint go? What? Shouldn't there be a PowerPoint? Did I download the PowerPoint? Hello? Download. File moved? What? Download it one more time. Now we should have it at download. Okay, and then we need to open this. I don't have PowerPoint either. Choose another app. Who can open PowerPoint? Oh, I can just turn the PowerPoint to PDF because there is no... Oh, yes. PowerPoint to PDF. I mean, I can do it from the terminal. You wanna do it from terminal? But I can just do it this here real quick. It doesn't matter. Just I'm gonna get like 20,000 advertisements probably. That's how this works, right? Bro, can this camera focus? Let me clean it. No, now it's focused, but it doesn't matter. How bad does it look in OBS? Let's see. It's okay, I guess. I know how you guys listen to me, but this should be PDF. Okay, good job. So we go to Obsidian, I guess. Yeah, I need to remove some things from Obsidian. I need to go to semester 3 here and remove many things because I've messed up my index very hard. What I've done is, because I've put like for software engineering, I've put like the homeworks in here to reveal in File Explorer. Oh, should remove these things because these are like big things. Don't keep them there, and then I'll remove it after I finish them. And just do this. Maybe I need to hold up. Look how much faster it will load now. Let's see. Look how much faster it is. Like, those things have big indexes, so it's hard for them. So we need to go to databases. Databases, labs. No, I need. Let's call a new file transaction management questions. I don't know how to write management. Is this? Oh my god! I don't know how to write management. I forgot this. Nice. Okay, so I mean we can put the PDF here, but I just don't want to put it in here. I'm gonna go to downloads, and I just want to take the PDF and put it in Obsidian. Not in Obsidian, in like the folder that Obsidian is. So transaction management. Should I make a new? No. Why here? Why here? Just. I mean, I can make a new folder in here. And call it transaction management, and then put it in databases. And then here in transaction management, put the PDF file, and I can put the questions. So I also need to open Anki for this. Anki, the slowest app in the entire world, but it's okay. It's actually better than Discord, not gonna lie. And then okay. Let me see something. How much resources does oh, why do I oh, it closes the chat. Okay. I want to see view, and I want to docs, chat. No, I want to see the. Why is this camera not focusing, bro? I need to clear this up. You want to see my desk, or you want to be cleared? Ooh, you're cleared. Okay, now can you work? Oh my god, I am gonna break this. Okay, okay. Nice stream, bro breaks his whole computer during the stream. Okay, what? No, I want to see, let's see stats. I want to see the stats. So we're using 2% of my CPU, nothing at all, it doesn't matter. And then we're live and dropped frames, 0, total data output, bitrate. It's not bad, I guess. It's not bad, so the stream should be good, maybe. What? Syncing failed? Anki web. Anki.web. Oh look, wait a second, you won't look what I type. But this email doesn't exist anymore. What? Email delivery failed. But oh, I did it with this, but this doesn't exist anymore. I need a new email. And what I do is that I turn your 360 around. And now you see nothing what I type, you just see me. Hello. Oh, let me see how does it look in OBS. Okay. And you have a big number of characters, and then you don't need to look. How do I please OBS don't record my screen? I'm joking. Oh, I can just I'll stop you from looking at my things. Okay, now you see black screen, it doesn't matter. Just let me type something. just fix this Anki real quick. Oh, Gmail. You wait there, guys. I know it doesn't look good, but just wait there. Insane. Oh, I have a lot of text. Now I think you can see, right? Now I turn you around 360. Oh my god. You should be up and running. And then I turn you on. You can see now. Wait. These are all my decks. I have insane amount. I have 38. I don't have a lot, but I have a lot of decks. And then let me refresh. Okay, let me sync. What? What is my web ID? I have. Oh, maybe they want the email. And then they want the password. And I won't tell you that. Go away. Go away. How to not show people your password? I should finish this before stream. Oh, it's synced now. Welcome back to my I got 360. Okay. And then let me turn this on. And here we are synced. It should also be synced in my phone and every way. But okay, Anki is opened, and then we don't need this anymore. And you ain't seeing. Oh, okay. And what we need is OBS, and if I remember, I have this Anki plugin, but I have no idea, like which, oh my god, which folder was it in though? Clavis? No. I want okay. I remember SQL had this. No, so transaction management. So we have transaction management here, right? So we have deck, and we call it DB, and we can call it transaction management. Oh, and this just creates a transaction management immediately at Anki, and we can start doing our questions in here. But I will also open the slides. And here I will open the transaction management. We'll make it full screen. I hope you see. I don't know how much you see, but this goes the other way around because I'm used to this. So let's learn. Agenda. Okay, basic term: transaction, item, operation, serializability of schedules, concurrency control. Okay, deadlocks and live locks, concurrent process, transaction models. Transaction. Okay, in a single execution of a program composed of read. What is a transaction? First question. You know, those are dumb questions. It's like questions here. So, single program is executed. Single program, and here I need to flashcard. Execution. Just execute a simple program. Execution of a single one execution one time. One execution of a single program. Because this is so badly written, right? A single execution of a single program. No, it's one execution of a single program, and that one execution is a transaction. And then, what is a transaction, and what is it composed? Can I just do that? Yeah. What is it composed from? Read and write operations. Yeah, but it can be a query or multiple query statements. It's composed from. What is it expressed at? Expressed with. Written. That's bad. What's expressed or written? Query language. Okay, and then what I do, I just do Anki. And then, okay, I do it one more time because the first time is just does a connection to Anki, and the second time it should save files. Databases here, and here we go. And we should have a first question, but we don't. But then we do it one more time. Hello file. Maybe do this. Because, yeah, I should do it immediately after this, and not in a new line. I see. And you get the idea. This is the idea of the question. So first question, second question. Can several independent executions of the same program run in progress? Do you like this music, or do you want some other music? Well, I can't see this chat, right? How do I make it not close? Can you not close? Can you, like, I want this to close, but not that to close. What is OBS doing? Can you, I don't know. Probably you can. There is no one in the chat either way. It's okay. I can maybe, let's see, I don't wanna show you, because I may show you like data you don't need to show, so let me try something real quick. Let me try something. Data you don't need to show, so let me try something real quick. Okay. Watch this. No, watch this. Insane. Look. Now I have you here. Haha. I mean, I won't write anything. It's me and me. Wow. I become Rangos, like no one around. It doesn't matter. Can several independent executions of same run in progress simultaneously? Give an example. Queues. Independent. Can several independent executions of the same program? Independent. What is an execution? No. If you have, so you're saying if you have the same program, the same, let's say, program .query or .exe, whatever you want, and you run it several times, and it is requesting in the database, and it's requested the same place, and if you run it simultaneously, it doesn't work because it's just changing the data without managing how it changes in a way which is like good, so you don't get like paid data. Because when you access the same memory space and then several things are accessing the same memory space, they should make sure that they don't mess up with each other, right? Because they're accessing at the same time. So the problem is that this shouldn't happen, so we need to rearrange them somehow. So one more thing is where are all the computations of a transaction performed? Well, the idea is that the transactions are performed in a local workspace, and then they are committed to the database. So you read from the database, right? And you read it into your local space here. you lead it here from a database, and then you work in a local space, you mess things up, and then you commit to the database. Right, so you don't have work directly in the database, but you work in your part of like where you have your data, for example, a small data on your computer, and then you work with it, and then you commit it to the database, and that is better. It is better because it's more easy to manage at the end, because everyone is just immediately just doing things in the database. Every transfer is just such mess up, and if you mess up in the database, then big time problem. Example, money transfer. Okay, if you want to withdraw some money from the ATM machine, does withdrawing money contain a single step or multiple step? Executing this series of steps must meet some requirement. Yeah, atomic, all steps carried out or none. What do you call this? Properties? What transfer transaction? So what should the transaction be? What are the properties that the transaction should have? What are the properties that a transaction should have question mark? Well, it should be atomic. What does atomic mean actually? All steps carried out or none? All steps carried out or none. It comes in atomic, is that it comes in one. It doesn't come in smaller pieces. That's the meaning. That's why it's called atomic, because atoms. What atom mean is you cannot separate it further, and then what atomic, it means it comes in one piece. It is. All steps are carried out. Yes, it is atomic. It's just the steps are performed in one piece. Or you can just performed in one go. Yeah. Consistent, only fully completed transactional effect. Consistent. Should be consistent. What does consistent mean? But should the database be atomic? Or the transaction be consistent? Yeah, it is properties of isolation, but what do you mean then? Consistent transaction. It's fully completed. I guess. Yeah. Fully completed. If you don't like, I mean there is no one, but if you don't like the classical music or anything, you just write. I don't know what kind of music I do during streaming, because it's my first time streaming. I don't even know how it looks in YouTube. It probably looks really bad, but who cares? We're gonna be better over time. Completed, I can't write completed for some reason. Completed, okay. And then it should be isolated, acid, there should be acid. And then isolated. Transactions are unaware. You see, to be unaware of other transactions when they are performed, you need the local workspace. The transaction only works in its local workspace and doesn't know about the others, what they're doing. From other transactions, no one knows for each other. And then we have durable. Yeah, what is durable? So the effects are saved. Preserved. Okay, and this is a flashcard. Well, idea why I do flashcards, because I can just learn on the go. So for example, let me do. So then if I open this, I have like 3 flashcards in here. I can just learn, study now, and I have like, for example, what is a transaction, what is composed from, what is it's like, what is the answer, and I just save 1 minute again, right? That's the point. Let me can I exit Dex? I'm out. Okay. Now let's do data items. So did I mention here they should perform read and write operation on data items? Operation on, this will get updated on data items. Okay, nice. What is a data item? Well, a data item is like a table or a row, it depends. It's like units of data to which access and control. Yeah. So you have, what is a data item? Data item. A data. It is a data unit which can have access control. Which the access can be controlled. Which the access of to it can be controlled. How do you write access more or less? Okay, so it's a data unit which the access to it can be controlled, right? So that's the point. For example, you can give access for the letter in the database, but does it make really sense? No. So you give access to like a row in the database or a table, and that's a data unit, a data item, I mean. And it should be partitioned with height, just because that's how you save things. Like you save things in a table, right? And then you give items to different transactions, and that's how it works. The size of items used by system called granularity. The size of items. Yeah. What is granularity? And then you have what is granularity? And well, it's size of the data item. The size of the data item used for transaction or for access control, right? And then you have, what is it called? I should ask, right? What is it called when size of item is small and other way around, and vice versa. Well, fine grained. Probably never gonna ask this question, but I'm just fine grained. It's small items, yeah, because it's fine grained, like it's in typical English. And coarse grain, I've never heard this one though. Coarse grain. This one is just large items. Fine is very fine, small items. Coarse is very big ones, I guess. And we have how big is this? Oh my god, we're just in the beginning. It's okay. Data item, a schedule. So you have a schedule for a transaction, or you have a schedule for all transaction? Of the transactions, read, write, and so on are executed. So what is What is I don't like one more. Schedule. Order in which steps. What are steps? What are steps? Steps. Read, write, or relations, and then you have order in which the steps of many transactions are executed. Okay, the order in which the steps of many. Yes, exactly. That's what the schedule is. And then you have scheduler. It's a portion of a database system, administrative system of a DBMS, I guess. Is a scheduled part of the DBMS? That's a question. Oh, let's ask the one and only who knows nothing and everything. Is the scheduler part of the DBMS? So it's not typically considered part of a database. Wait. Think. Yeah, types of schedules in DBMS. DBMS scheduler. You see, so it's part of a database system. So what is a scheduler? Scheduler. Oh my god. Scheduler. What is it part of? Well, I mean, these are just questions to like understand small things, and then we have like hard questions. We need, not hard, you just need to think logically. This is like learning. So it's just, why they call it a portion? No, it's just a program which is contained in the DBMS. A program in the DBMS, which yes, arbitrates a conflicts, which arbitrates the conflicts. Yeah, a program which it arbitrates the conflicts, and oh my god, I'm gonna break this thing alive. The scuffiest stream in the world. And then so we are arbitrating the conflicts, and what else are we going to do? Control access rights of transaction. Controls access rights. Yes. Takes care of access rights. Takes care access rights for each transaction. One more S. I mean, should I like do this DBMS and then arbitrate conflicts? Access rights, and then I can say takes care controls access rights, arbitrates conflicts, controls access rights. Or just say, I can just say in DBMS arbitrates conflicts, controls access rights, right? Schedules. Schedules. Not schedulers, schedules. What are the types of schedules? What are the types of schedules? Schedules. And this is what are the types of schedules you have? So you have serial. Yeah, serial is just the worst one, right? I mean, I just know what it is. Non-serial. And then we have non-serial but serializable. Non-serial, non-serializable, and serial, but unserializable, I guess. Is it unserializable? Serializable, and then you have serializable. Does this word exist? Or am I just... And why do I have like different, how many Firefoxes I opened here? Close this one. Serializable, yeah, unserializable. Was right. And why this is not? Hello? Ah, okay. It doesn't matter. Okay. Next question. When is a scheduler serializable? So when is it serializable? It's such a bad if and only if, right? You said if its effects are equal to a serial schedule, and then you say what are its effects if the serial equivalent exists. If and only if the serial equivalent exists. Serializability of schedules. We use spot the serial and non-serial schedules parts. Do serialized schedules exist in practice? Okay, use what? You spot the serial and non-serial schedules parts. Do the serialized schedules exist in practice? Why? Yeah, serialized schedules exist. Yes, because you want to make everything serialized in a sense. Serialized. I mean, serialized, yes. Serial schedules are bad because like just putting every transaction one after another it doesn't make any sense. But if you have serialized schedules, they have like parallelism, but it is serialized in such a way that everyone waits a good amount of time, so it's not like overall, no, it's like pretty good. It's like parallelism in a sense. It can be serialized, but you execute it in parallel. Parallelism, no conflicting parallelism. Now it makes more sense. And then what is this? This is, you can read A, read B, read B, read C, you can read D, write E, so you have no problem at all. So this can be serialized. This is a serialized schedule. You can be serial. This is a non-serial, serializable schedule. So now you have serial schedules. Okay, what are the properties, right? If the serial equivalent exists, if all these properties hold. Ah, no, these are the differences. Serializable. No concurrency is allowed. Concurrency is allowed, so several things can access at the same time. As all the transactions necessarily execute serially, one after another. No, multiple transactions execute concurrently at the same time. Okay, shall lead to less. Yeah, Yes, so you have parallelism, so you have more throughput, you have more CPU usage and so on. Yeah, and this is more efficient. So let's read this real quick. So what's the problem with this? So you read, this is type 1, you do this is just serial schedule. So you first do T1, then you do T2, and this is like parallelism. But this is like, I think, bad parallelism. Because you read A, right? And you read B, and you do a calculation, and you do the calculation on B. And then you write A, and you write B. And then when you read B, the B has changed already, and then you read C. Right? But there's no problem with this. I think it's pretty good. I mean, if this... The point is that T2 comes after T1, right? But T2 is writing B and this is reading B, so T2 is changing B before T1 can even read it. So maybe that's a problem. This can work though. C can work because you read A, you do this, and then you read B, and you perform the operation, but you still don't write it. You wait for T1 to read B, and then you write it, and then everything happens. Good. So this 30 type of schedulers, and this was serializable, this was non-serializable and unserializable, and this was, I mean, non-serial, this was serial, non-serial unserializable, and non-serial serializable. And then discussion. Okay, is it possible to prevent the schedule of figure section C from occurring by having... Is it possible to prevent the schedule on figure C? Figure C, yeah, from occurring by having all transactions lock before reading it? What is wrong with this? What is wrong with this? They think it's wrong with this. Oh, they think the other way on. Why is C wrong? Because you don't say that I've written to B, so you're reading B without even writing, that's a problem. It's such a stupid, like, why? That's the point. In figure section, yes, you can, it is possible if you lock them. Locking works every time. So you're saying C is non-serializable because you don't write this? Because you don't write B before you read it? It's saying non-serializable? But you should ask, you should ask conditions in here. You should say, because when and this guy writes to it, right, he changes it, and maybe you, this gives you a different output, right? Because when you read B in here, it is what's the old B, and when you read B in here, when you read B in here, it's a different B now. B in here is a different B now. Depends what you want to say. Or maybe T1 and T2 comes at the same time, but this gives you a different output and this gives you a different output. But maybe if you think as a money, right? Let's say B is a bank account, and you have minus. Okay, you do minus 20, and you're right. Then you add 10, and here you do minus 20. You read and you add 10. It's. I don't know where the problem with this is. However, it is not possible to test whether two schedules have the same effect for all initial values of the items. Exactly. If arbitrary steps on the items are allowed and there are an infinite possible initial values, you assume that values cannot be the same unless they are produced by exactly the same sequence of steps. Oh. However, okay. It's not possible to test whether two schedules have the same effect for all initial values of the items if arbitrary steps on items are allowed and there are an infinitely of possible initial, because this is a different initial condition, so this gives you a different value from A. I can add one more questions in here if I want to. I can add questions. I can just put it here. I can say saying it says that but no, the outcome at the end of two transactions is the same. Yeah, if both transactions come on time, that's a bad question. Because if both transactions come at the same time, they both are going to be performed at the end. So at the end results, not right here, the result right here in the middle of the steps, the result at the end of the steps. The result at the end of the steps is the same, and this is the only problem we have. And the effects of this are the same as the effects of this. The only problem we have is because before writing we read it for no reason. So now we have concurrency control, how to control when we access the things at the same time. How is this, how bad is the stream going? Oh my god. Oh, we are 1 hour in. Okay. Let's see, let's go to my channel, yes. Can I go to my, this just goes to your channel. Let's see what's happening. Hello. Oh, we are 1 hour in. Okay. Let's see, let's go to my channel, yes. Can I go to my, this just goes to your channel. Let's see what's happening. Hey, I'm the only one watching, let's go. Oh. Bro. Probably sounds so weird, right? Okay, this music is... Can I... Okay, I'm gonna get copyrighted, right? But please. Probably gonna get copyrighted so hard. But please, I want some of this music. I don't know how much you hear it. I'm gonna probably make it a bit smaller because I don't want it to be too much. Oh my god. Please turn on. Oh, yeah. And just look this. Pam, pam, pam. I don't know what YouTube shows, so don't mind me. We're learning. We are no one. Okay, concurrency control. It is the management of two simultaneous transactions to execute without conflicts between each other, such as in multi-user systems. What? Yeah, management of two simultaneous transactions. Execute them without conflicts. What is concurrency control? What is it's such a stupid question though. But just finish it fast. What's just concurrency control? Well, it is managing a non-conflict execution of the first time I learned this word was in general theory. No, in general, just theory of not probability, the theory of relativity, because simultaneity, right? It's very important there. Conflicts, managing how do you write that word? Conflicts, non-conflicts, managing non-conflicts. It's not English though. Managing non-conflicts execution of simultaneous transactions. That sounds very bad, but it's okay. Non-conflicts execution. No, okay, an execution without conflicts, but non-conflict. Conflict. Maybe it sounds better. It's not right. I just moved it. Okay, the simultaneous execution of transaction over shared database can create several data integrity and consistency problems. Yeah, because it depends how you access. If several lines of programs are accessing the same data, then weird things can happen with it. What advantages of concurrency control you can think of? It makes it so much faster because you have you're performing, you're using more of your CPU, you have more throughput and so on. Oh, this music, bro, is insane, the funk. Okay, concurrency possible problems. Cases to avoid with scheduled problems with schedules. Uncommitted dependency or dirty read problem. Inconsistent retrievals. What is a dirty read? Let's see. So I would ask the question what are the possible list let me type fast. The possible concurrency problems. One, you have 30 read. I mean, I need to explain each one of them, but explain each one of them. Okay, so what inconsistent retrievals? What you call that inconsistent? Oh, hello. Oh, no, no, no. Now can you hear me? You've been not hearing me for a long time. Oh, hell no. Okay, I'm back. First stream, I need to learn these things because they can happen, right? So I need to... Oh my god. Are we back? Can you... Oh, yeah, you can listen to me again. Oh, hello. Oh, no, no, no. Now can you hear me? You've been not hearing me for a long time. Oh, hell no. Okay, I'm back. First stream, I need to learn these things because they can happen, right? So I need to... I broke it again. Oh my god. Okay, we move on. Just move on. List of possible concurrency problems, yes, and then the second one is lost update. What is a lost update? So we have T1 reading a value, so we have lost update. So what's happening is T1 is reading a value, so we read what? So transaction 1 reads it, right, and it writes it, and then we have transaction 2 which writes it. Transaction 2 commits it. But how does transaction 2, like, you write without reading? What? Lost update. Which update? Ah, you mean this update was lost. Yeah, T1 reads a value, let's say 10, T2 updates it to 15, let's say in the buffer, right? T2 does a blind write. T2, right? Without read, right? Without read, yes. When you do a, because it didn't read here. If it has written here, then when it committed, it would make sure it would right, I guess. Yeah, but you have a write after write dependency. Because you're writing immediately after you're writing and you have a lost update. But this is like the write after write. Because you write after you write and you lose write after write. And what is a dirty read? A dirty read is different. Dirty read, it's failure. It's like a write after write dependency. Because you write after you write. So, lost update, yeah. Now we have, oh, we have another example. So we begin, you probably can't see it, but like, can I zoom in? Oh, it's not good. So you begin a transaction, you select from accounts where owner is Bob, you make balance 100 and you update the balance. And then you select from accounts where owner is Bob and update the accounts where balance 60. So you set it to 70, right? And this guy sets it to 50 and then you commit. Oh, so you say, let's say T1 bought $50 and then T2 bought something with $30. Then the last commit would be $70. So we lost the update of when we bought with $50 in here. I see. Last updates are very crucial for, how do you say it? The companies of banks, I guess, transactions in the banks. So now we have unrepeatable read. So unrepeatable read. This problem occurs when a transaction gets to read... What? This occurs when a transaction gets to read unrepeated? Is this even English? That's not even English, professor. Oh my god. T1 reads the value of x equals to... Okay, let's see the picture. Pictures are all here. So you read x, and you write x, and you read x again. And they call it unrepeated read. This is just read after a write. You are reading after you're writing. Yeah, because it's right after a read. Because like this guy is like read after right. So read right. Oh my god, I need to change this. It's right after right. So right after right, a raw, and this is a raw read. No, this is a read after right, a raw dependency. Yes, these are very bad because you write and then you read, and you were saying, well, how did it change? I didn't do anything, and it changed. I just putting the picture and maybe a bit description. Maybe description is how come how T2 asks how come asks. I cannot write asks for some reason. He wonders how come X changed. Oh my god, my English, my guys, wonders, please. Windows, yes. Windows, yes. Oh, wonders. Wanderers. What? Meaning. No. Wonder. In meaning, just meaning. Who said indie? Yes. Wonders. I was... If I'm right... No, I'm not. You just need one S. So never mind. And then I just... Thanks, I guess. T2 wonders how come X changed. Okay, okay. And then we have phantom read. We read nothing. And then we have phantom read. Phantom read. Reading a deleted item from another. I mean, I probably should do this. And phantom reading. T2 wonders. And I always wonders. So T2 wonders how come a deleted item. So T2 wonders what wonders who deleted X. Possible solutions. Okay, I probably should have made them all separate, but even though they are together, it's no problem. I just do a quick Anki here. Okay, and let's see how does it look. Browse the deck. Yeah, it looks pretty good. And then a conclusion, possible solution. Having a serial schedule is a solution, okay, where all the steps of each transaction occur consequently, yes. Yes, serial schedules. What are other possible efficient solutions? Locks. Serial schedules are extremely good, but our possible solutions are locks. You lock items, so you only give that to specific things. Serial schedulers are the best in a sense because they work most efficiency in the sense, like can make them work very efficient. But sometimes locks are just better. Let's see what ChatGPT has to say for this. Let's make a different thread. This one looks pretty dumb, don't go away. Let's make a different thread. Limited parallelism, potentially leading to slower execution. Oh, serial schedules? Serial schedules are bad. I thought it was asking about serializable schedules. Serial schedules are very bad because you're doing everything one after the other and it's like, what? And it's so slow, you're not using your CPU, so it's very inefficient. Yeah, parallelism, so we need to serializable things. Or logs, we can use logs. Okay, we are halfway there. Not even halfway, we're 1/4 there. Or 1/10. We keep moving. Concurrency control techniques, a scheduler, okay. Lock is access privilege to an item for a transaction. A lock is access privilege to an item for a transaction, which the lock manager can grant or withhold from transaction. It stores the current locks in a lock table, which consists of records, data item, lock type, transaction. Okay. Lock is access privilege to an item for a transaction, which the lock manager can grant or withhold from transaction. It stores the current locks in a lock table, which consists of records. Lock type, transaction. Okay, so what is a lock? What is a lock? Is access privilege. How can it be an access privilege? Is a access privilege. You can say it's an access privilege. It's a very dumb statement. It's an access. It's an item you use to give. It's an item you provide access privilege. Okay. It's an access privilege. Because there are different types. Access privilege. I don't like that at all. I would say it's an item you use to grant access privilege, and then you have different kind of items you can use for access privilege, semaphores, locks, and so on. This is a lock. Who manages the locks? Lock manager. Manages? Who manages the locks? The lock manager. Who manages the locks? And how are they stored? I mean, it's called a lock table. I have a lock. Man, I should. Lock table stores it as data. Oh, I can't do that, but I can. Data. Can I just lock type and you have it, or I can. Let's see what happens here. Yep, you have a data item, you have a lock type, and you have a transaction. Because you give a lock for a data item to a transaction. That's why. Use what is the meaning of ILT? What I is the data item, or is the lock type is L. I don't know what the lock of type L means, but okay. And you have a transfer transaction T. on item I for transaction T. Queues. What is the key for lock records? Why? It is the record, is the lock type, maybe R or like for O, right? And then you give it a transaction. Concurrency control, relationship of a log, manager, scheduler, and protocol. So you have transactions following the protocol. But we did, what is a protocol? It's a set of rules. You never mentioned what a protocol is. Need to ask what the protocol is. What is a protocol? A protocol is a set of rules. We have log table, log manager, schedule, transactions following protocol, request log. So the scheduler is requesting a log to a log manager. That doesn't make any sense, but okay. So we have a transactions following the protocol, they request a log, and then grant or deny, grant access, wait or abort. So a log, oh, it talks with a scheduler, I see. So transactions talk with a scheduler, right? They work with a schedule, they request a log, and the scheduler grants them a request to a log, and then the log manager grants or denies a log, and then the scheduler grants access, waits, or aborts the transaction. Let's see, what does it say? Set of rules, yeah. How the transactions are done. How the transactions are done. Are performed. Flashcard, and then give explain with a drawing what is the concurrency control of log manager scheduler and protocol scheduler. Where is the protocol? They work with the protocol, I guess. The protocol. This is very weird what I wrote, but keep moving, because you don't put and then you have okay. Now we have concurrency control techniques. Ooh, wait. Classical music is not copyrighted, so we can put some classical music. This is going to drive me insane. I love classical music. Oh, Chopin, the man, the myth, the legend. Debussy was so good. Dun 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 dun. Banger music. My man is a legend. Why do they not? Yeah, Hello, no one in the chat, let's go. W stream, what is this point in here? Never mind. Concurrency control techniques. Locking. A transaction request to lock items. The transaction requests to lock items to perform some steps. After completion, the transaction releases a lock. Yes. How did the lock solve a loss update problem? Well, I won't ask a question about this because locking is very natural. You lock an item and then other transactions wait until it's unlocked. So this is a good question. How lock solve a loss update problem? How can a lock solve? How can a lock solve the lost update problem? Because you're locking A, right? And then this cannot use A until this thing happens. So until the transaction 1 commits, you cannot use A, and then transaction 2 commits, right? So T2 waits in here until A commits completely, so you don't have a lost update. T2 waits till T1 commits. So the update is never lost. Deadlock concurrent processes. Okay. Suppose we have two transactions, T1 T2, whose significant actions as far as concurrent processing is concerned are T1 lock A, lock B, unlock A, unlock B, lock B, lock A, unlock. Okay, this is a deadlock because T1 wants A at the same time T2 locks B, and then you can say like this, we can LA, so you lock A, and then you have lock B, and this guy requests a lock on B, right? Lock on B, and then this guy said, I need the lock on A. Oh no, you're in a deadlock. Because this waits for this guy to release, and this guy waits for this guy, so you're in a deadlock. And you can say unlock A, say unlock B, and then you can say unlock A and unlock B. I mean, unlock B and then unlock A. I mean, you can do it like this. Explain a deadlock. Yeah, and then you're deadlocked right here, like you can't move forward. You can never unlock A because you need to wait for B, but B is held by A. But B is held by B, which wants A, but A is held by this guy, so you never can request. Just waiting. Deadlock and explain. Who aborts? What happens then? What happens? What happens after that? What happens then? A schedule. Happens then. The scheduler aborts one of the transactions. How did they draw it here? They did students hold T1, it holds T2, and it requests T2, it needs T2, but it holds T1, and this guy needs T1, which is held by this here in the deadlock. Deadlock, avoidance, detection, wait for the graph, yeah, this is the image, okay. So waits for T2, waits for T1, this is how it looks in the precedence graph. Yeah. Scheduler decides. Example. How does it look? How does it look in a precedence graph? Cycles. Questions. Are all the cycles deadlocks? How is it? Forgot the name of the graph. It's called the precedence graph. Are all the cycles in the precedence graph? So are all the cycles in the precedence graph? The precedence graph deadlocks? How would it look? Let me ask generally. How would it look though, right? Because my question is... Because my question would have been like... if you have, for example, T3, right? You say T1 wants T2, T2 wants T3, and T3 wants T. Yeah, all the cycles and precedence graph deadlocks. That's such a good question. Well, deadlock possible solutions. So let's say, what are the possible solutions? These transactions request all its locks at once and let the lock manager grant them all. If what are the solutions? Good. So what are the solutions? It's a So request all locks at once, so you don't have a deadlock. Nice. Request all locks at once. Nice. And then assign an arbitrarily linear ordering to the item. What? Ah. This is such a good solution. Oh, so you give an order to locks of items, to a locking of items. Because the idea of this is because here, for example, what would have happened is I can just throw this, right? So this would have looked like this. Well, maybe it's pretty slow, I guess. Oh my god. So this should be moved. Oh, ay. This makes it serializable because I'll just what keyboard am I using? So you do something and then you do something too. Somehow, well, it's the same, I think, because you request A and then you need to request B. No, it's not the same. No. So first you request A and then you request B. Now this works out great. Pretty good, right? You can see that it works. Nice. why this might be beneficial as a solution. You have deadlock prevention, you can analyze and prevent it, and you have ignorance. You can ignore the deadlocks. What? What do you mean by deadlock ignorance? If we go to translate, I guess, let's go to just see what it says. Critical systems, yeah, in critical systems we have prevention, but sometimes ignorance is good. Because analyzation takes so much time to do, sometimes ignoring maybe it's better, like, but still, like, you have a database, it's a critical system, like, if it breaks down, like, no. Only if you have to wait for a long time and you need to do so much rollbacks, the users won't be happy. Well, it is like that, I guess. Live lock concurrent execution. Transaction models. Oh my god, it's a whole... How much more is there? Yep, but there is a whole... Okay. I mean, if we can do this today, we are golden, but it's so much, isn't it? Oh, when I render this, it's just, my PC just runs. This looks like a weird... Okay, where are we? This classical music price training is so much, so crazy, it doesn't matter. Live lock, current execution. Yeah, we're here at live lock. I mean, I'm gonna take a small... I'm gonna eat something real quick, or... just drink some water. Be back in like 5 minutes. Oh, so I don't know. I can just do that. Oh, when I render this, it's just, my PC just runs. This looks like a weird... Okay, where are we? This classical music price training is so much, so crazy, it doesn't matter. Live lock, current execution. Yeah, we're here at live lock. I mean, I'm gonna take a small... I'm gonna eat something real quick, or... just drink some water. Be back in like 5 minutes. Oh, so I don't know. I can just do that. take a small. I'm gonna eat something real quick, or just drink some water. Be back in like 5 minutes. I was just watching my own stream and looking if it works. Yeah, if you mute the button, then it just works. Which is so weird watching yourself. It's actually not, I don't know. It looks cool. I guess it doesn't. It's not the worst one. If someone's watching this, what are you doing? Oh, what? Someone is here? I don't know, bro. I'm just doing databases right now. I'm eating a banana. Well, I code in different programming languages. Like I use C, C++, Java. But I'm not doing a programming. This is just a study session. This is like, maybe one time I'll do like coding sessions. A study session. Yeah, I have projects in GitHub. You can, you have my GitHub, like it's just my name, I guess. You can just, let's see, Firefox. I have cool projects if you want to look at them. I can just, this is, let's see my project. Oh, let's see my whole project. I need your project, or like my repositories if you want to look at them. Like this is I just put it in the chat if you want to. But this one is cool. The integrated 3 is pretty cool. It's like Desmos, but I made it like in Java, and I don't know, it looks cool if you want to look at it. Probably. I can run it for you if you want to. Let's see, can I do it real quick? Hopefully, yeah, I can. So let's see, where is my, I can just run a quick, probably run maybe on it. I can, probably, I don't know, I code them different languages, but this was like a project I had for homework. Yeah, I just made like, this is a parser. Because you take this as a string, and you need to parse this, and it tells you if something is wrong in the parsing. Like you can display cool things, I don't know, you can color it, I guess, Java thing, and then you can move it and so on. But it actually works. It also works pretty fast. I also made it so you can open like JSON files. If you go to desktop, I don't know, where is my files? I think I put them some here. Yeah, just JSON files. You can just open them. It makes like cool stuff. You can like the UI part is cool, but like the background part on taking the string and then making it into an expression, is the whole story behind it is pretty cool. Because this is a tree at the end of the day, you need to make it into a tree. As you see, it's like, can I? Yeah, if I could have showed you, but it's not right now. I'm studying, so maybe you can look at it. I have a documentation also there, but it's just oh, I can just look at the documentation in GitHub, so I can just, or I have it right here. Let's see. Yeah, these are like, I just wanna see how a tree looks at the test. I think I wrote somewhere here. Yeah, for example, this is like for example, x to power 3 is just a tree in a sense, where you have the root is this thing, and then to 3 is the right child, and x is the left child, and then every expression can be turned into a tree, and you evaluate this tree to do the evaluation of the functions, because at the end of the day you only take a string, right? This is just a string, and you need to turn it into an expression where you can evaluate. And there is like cool maths there. We have like, you need to turn it into a different notation things. maybe you can look into it. It's like reverse Polish notation. Reverse Polish notation. Like, you see, for example, this picture. You see, this is reverse Polish. It's like you do 10 plus 5 and then 3 times that amount. It's just another way to write it. You turn it like this, and from this you can easily make the tree, and then from the tree you can calculate functions. Yeah, but that's all. I mean, you can look at it if you want to. You can even use it, download it, and do whatever you want. But is it public? Yeah, it is public. Just have fun. Yeah. Yeah, that's all. Oh, where did I put the chat now? Like, probably you're asking and I never wrote anything, but... Oh, thanks, bro. Thanks. Thanks, bro. Just right, bro, in here. I don't know. This is my first stream, so you're my first viewer, I guess. Hey. How do I like your comment? Can you do likes in here? YouTube, question mark. Hello, YouTube. Can I? Oh my god, I cannot press the 3 dots. Okay, I can. I don't know. Can I put a heart? I guess just put a heart. Me very new to this thing. Yay, hearts. I don't know. Thank you. No, I'm just gonna go with this thing. And I'm gonna eat this banana because I'm so tired. I'm just streaming for like 1 hour and my voice is dead. And where's my classical music? Because I'm not to get copyrighted, put some classical music. Live locks. Okay. What is a live lock? No idea. You know, a lock, like a lock is just you lock some part of memory so no one can access it except the one who has the lock. Just like a safe in a sense. But like live locks, I have no idea. I'm just learning them. Me? Oh well, I'm from a small. I'm actually from such a small country. I'm from Kosovo. You probably not even heard of it. Probably like it's just we declared independence in 2008, I think. Right? Yeah, I'm from this country right here, that small country. Yeah. But I don't live in Kosovo. I'm studying right now. Yeah. I mean, small country. Where are you from, man? Where are you from? Where are you from? Yeah. Well, I hope you and your family are doing fine, I guess, because of the war. Well, we supported Ukraine during the war. We don't support the Russian invasion at all. Well, we don't like Russians at all, not gonna lie, but because they have connections with Serbians, and then Serbians don't like us in a sense, so I don't know, we're pro-Ukraine. So I hope everything is fine. But right now, I'm probably gonna like start learning this. So if you wanna stay, but if you want, I guess leave. But because I'm not coding, if you like to learn like live logs and things for databases, this is like, say. A system that grants and enforces locks on items cannot behave unpredictably, yes. Just saying that, oh, so what is a live lock? It never tells you the definition. Yeah, I like this professor. It's pretty weird, I guess. They don't even... I think live lock is because, in a sense, you have transactions. So can I draw somewhere? Maybe I can just... I can. X call 0, I guess. You can, oh, it's oh yeah, I can just right here. In a sense, you just so you have like transactions, right? And they have object in here, they want a 1, and the problem transaction 3, and then this one wants the lock, and then it's granted the lock, like this one goes in, I guess, and then it finishes its job, and then T2 request during the T1 is 1 T2 request, but also T3 request, but T2 requests it first, right? And then the problem is, after T1 finishes, who do you grant the lock to, T1 or T2 to T3, right? They both requested, T2 requested previously, and maybe you give it to T3, and then T4 comes, you give it to T4 and not to T, and T2 maybe waits forever, so you need to like make sure that everyone gets the lock when it needs to. Thanks, bro. You too. You too. Thanks. Awesome people, awesome people. Good night's sleep. Have amazing dreams. Here I need to study it up. Yeah, this is like live logs, but they never give a definition, so what do they really mean? I don't know. So let's just search in Google real quick. Probably I'm gonna make like other sessions where I code, and probably it's more interesting than this, but right now it is what it is. First stream. What? No, wait, let me... Let's see, this guy is usually pretty good. So live logs is like concurrent execution. So live log is not an object anymore, it's just when something happens. Oh, live lock is kind of, I see. Not a deadlock, but kind of those parts when this shouldn't happen. So live lock is that. Suggest possible solutions. So what is a live lock? I just suggest that. Live lock. execution, which is live log. Starvation of a transaction for the lock. Transaction models. Now what is it? Okay, we have a transaction, we had the transaction like a protocol and the rules, and now they say transaction models. I don't get this, guys. What is a model? I know what a model is, but what is a transaction model? Simple transaction model. One type of a log, two transactions, cannot log the same items. What? Yes. So simple transaction model and the precedence graphs are models? So you're saying a precedence graph is a transaction model? What are some transaction models? Let's ask that. Yeah, so we have what? So the simple transaction is a model that uses a precedence graph. And then what are transaction models we have? And then we have protocol. I see they have not good separation in here. Like sometimes they mean something, and then the other times they mean something else. Like there should be a transaction models, and you list the models and you explain each model separately, and they just say a model and then move on. Interesting. What is? Oh, I just asked what is a simple transaction model? Pretty dumb question I asked, but it is what it is. Oh. Good luck. Oh, thanks. And good luck to you too, I guess. Whatever it is. One type of log. Oh, these professors are weird. They list things pretty weirdly, I guess. And here we have Halberd. Yeah, you need all of these. Oh, I see. He's a model and done. I'm joking. Should write like what is a simple? What does? What is? What? You see, even asking questions learns you a lot, because if you need to know what kind of questions you need to write. Hi, bros. Hello, hello. Okay, I don't know if you don't know what we're learning like how to have transactions and put them on precedence graphs. And then when you put them on precedence graph, you can like order them in such a way that like they can be serialized, but in a sense you can do them parallelly So when you do like database, when you request something in a database, like when you have multi-users, many users, you can do them at the same time, but without manipulating the data. So you manipulate the data, but you make sure that if the transaction one changes it somehow, that doesn't conflict with what T2 did. So you want to make sure that your database is, like we say, consistent. The data makes sense. So for example, I put $50 on my account, and then someone else remove, I am at the same time, let's suppose my mom put more $20. How do you make sure that if these events happen at the same time, they are you make sure that you get the right amount at the end? Because weird things can happen, and then we study how those things can happen and how can we eliminate those things. And yeah, we're here, I guess. We had weird. And then the simple transaction model is like the simplest way to do this. And the idea is that you just have a lock. So you have a lock. What is? This is such a bad question. I shouldn't ask a question like this. But it's like, what does it include? Yeah, the question should be asked like, explain the simple transaction model. Explain the simple transaction model. By the way, I think I explained it. Yeah, it's it's transaction management, because when you do SQL statements from databases, if you've ever learned, like when you request some data from database, for example, right now when you write something in the chat, is written to YouTube's database, and then for example my Firefox here, in a sense, requests from the database the data there, and then it shows what you've written, right, the comment. And then how the problem is when you have like many users, how do you take care of it, and what the problems arises. But this just scratches the surface, but in a way it's just math. Because they use like precedence graphs, if you ever heard of them. But it's pretty cool way to like make sure that when I write something at the same place, and you also, for example, write something at the same place, or if several users are changing the same thing, how to make sure that it works fine at the end. So we're just learning that. And we're just here. So you have one lock type. It means, what are lock types? They don't even explain what a lock type is. The lock type is just, for example, you have a read lock and a write lock. The read lock, if you have a read lock, I can read from something. If you have a write lock, I can read and write, because the write is like more important. Because you have more problems when you write something, because if you read the book and everyone reads the same book and nothing is changing, everyone can read it. But let's suppose you're also writing the book at the same time, like someone is also writing and there are like 5 people writing the book, and you're like, who's the one whose sentence is right in here, or how do you take care of that? And that's what and the simple transaction model is like, I think, the simplest thing you can have. You have just a lock type, one lock, read, like only, you don't separate it into read and write locks. You just have a lock. If you get the lock for a table in the database, you just get the whole table. You can read and write into whatever you want. But in different models, you, for example, have a read and you separate the locks, different type of locks. And then you have 2 transactions can log the same item. This is general. Like if I have a key to a safe, I am the only one who has the lock. So, and there is like the lock managers who gives you the lock, which transaction can have a lock, and so on. And then how do we put the transactions in parallelism so we can work out more CPU? We can use more CPU and more throughput. And then we use like a precedence graph to calculate the things. And for example, let's have this example right here. So you have T1 and T2. And the point here, for example, T1 request is at item A, at table A, it requests a lock to use it from a lock manager, and then it unlocks it right here. And then T2, for example, requests a lock, and it should wait. It can request a lock in here, for example, somewhere, right here, if you can see it. It can request it earlier, and it should wait until T1 unlocks the lock and until it it gets a lock, it is granted a lock. So T2 should wait for T1, and when you represent like complex things like this, and then when you represent like this, we can turn it, we can, in a sense, it's called, we can serialize them. And then that serialization we can do, and that's the way we execute then the transactions. But that's like the whole thing about it. It's not like extremely hard. But if you know a bit of like graphs or like a bit of graph theory, it's so much easier. So yeah, what is a precedence graph? Nodes represent a transaction, and then you have edges between them. What is the dependencies of granted lock? So this is how locks A, and this wants the lock from this guy, and it waits until it unlocks the1. So this is like waits for unlock here, and then it locks here. So and it's saying if and only if a precedence is a direct cyclic graph. Why is it saying this? Is because if you have a cycle, I can draw, right? So I can just, if you have, let's say you have T1, T2, and the DAG is when you have no cycles. What is a cycle? For example, this is a cycle. You see, you can go around and around. That's a cycle in the graph. If you have cycles, then this is a deadlock, because T1, for example, this locks A, and this is locking B, right? And then for this to proceed, this T2 wants the B lock, and this T1 does the A lock, and they're deadlocked because they lock each other. I mean, I explained it up here previously, but they lock each other, and then you can see it immediately in the graph. And the thing about when you represent things in the graph, when you compute things in programming, it's so much easier because we have so many algorithms. We have so many algorithms on how we can do the graph things. We have so many graph algorithms, I call them, and we can just draw the graph, make the graph real quick when the transactions come, and when we make graph, just apply the algorithms we have, we can find these cycles pretty quick, and we can just like remove them and decide how to remove them, and then we just make sure that everything works fine. And we're pretty sure because the algorithms are, the graph algorithms we have are like pretty good. We like, it's a lot of math when you think about direct cyclic graphs, but the algorithms are already made by other people, so you don't have to think a lot. But okay, let's move on. Discussion. How many programs are trying to modify a record A? What are the possible real-life problems in the structure? Oh, so we have so we have a database, and then we have a local workspace. So we have 5, it reads 5, it reads 5, and we have, it makes it a 6, it does nothing else, it makes it a 6 too. And then it writes to A, I see, it writes a 6 and it writes a 6. So you see, this is a lost update because you updated it to 1, but you get 6, not 7, because this was lost. Because you wrote this, but you overwritten it here, so you lost it. This is called a lost update. So how locks control concurrency when transactions execute in parallel? How locks control concurrency when transactions execute in parallel? So let us consider two transactions, T1 and T2. Each transaction accesses an item A, which we assume has an integer value. Yeah, did I just read this? This is the same thing. Yeah, it is the same picture. Now we have locks in here. Oh, I see. But they put the same picture. Oh my god, this professor is bros. We assume that the integer value adds. It's just saying if you had a lock, then you could not read, you could not like write to this, so you would make sure that this updates it first and this updates it first, the A. Possible solution. Okay, the most common solution to a problem. right? Just locks. A marks. Just lock A until T1 finishes and then give a lock to T2 so T2 can do the other things. But that's not a very efficient way, by the way. A lock command is executed by a transaction holding a lock. Yeah, a lock manager locks records for transaction when it requests it for a specific item. Each transaction will unlock any item it locks eventually. Yes. And now we have a two-phase locking protocol. This is like the important one. Two-phase, because you first lock everything like this and then you unlock everything. Well, we have a log. And then you have a precedence graph, I guess. Just do this. Graph. And then it's nothing new, I guess. This is important. What is this thing? What is the phase between locking and unlocking called? Oh, it's just synchronization point. It's called we call it 2PL. 2PL, okay, so we just have synchronization point. Synchronization. Oh my god, my English. Synchronization point, right? A two-phase locking protocol, okay. Transaction obeying this protocol also to be two-phase. The first phase is a locking phase and the second phase is an unlocking phase. Okay, you can ask what are the phases of a 2PL, maybe? That's a better question. What are the phases? How do you write phases? Oh, it's phases of the 2PL. I mean, 2PL, I guess. It's unlocking It's first locking. Oh, it's just about like in databases you have transactions. For example, when you request an SQL statement, I know, simple SQL, you just say, for example, select. You select from a table, select something, I guess all of the columns from a table, from table, and then blah blah, you do something, right? And then you have so many writes and reads to the database, and then you have so many users writing and reading, and then one code, like one select statement or many select statements put together, they make a transaction. And these transactions, everyone does a transaction. For example, right now you wrote a comment, and that comment was set to like YouTube database, and that's like a transaction. And then how do you manage when you have like many users? Because when you have many users accessing the same data, writing is a problem when you write the same data, because someone writes it and then someone at the same time writes something else and it is overwritten, and then how do you make sure that this overwritten of data is done precisely and you don't lose data? And then you have so many problems that come out from it. And how do you solve those problems? That's like the main. And then we create some kind of rules for when the transactions come to the database. We create the rules, and we call them protocols, in how to handle this kind of transactions in such a way that we have a lot of parallelism, in a sense that we can do them in parallel, so we can utilize our CPUs, and I mean, we can utilize the servers, but at the same time, we make sure that the problems that the parallelism creates are resolved. And then we have like protocols we make, and then precedence graphs to make sure that the, in a sense, bad things, not happen to the database. And we're just like learning that. I mean, it's called transaction management in the database, but the general thing. And then how to create schedules and how to serialize them. And it's like, this is a specific protocol we're learning right now. Well, the protocol is pretty simple. You lock what you, for example, you want to use table A or row A or table B, it's just an item. You log them first, then here you do your transactions, and then you unlock them. And this is called the synchronization point. Yeah, exactly. This is like a deep dive. Like when you install MySQL, for example, this is already included in it. Like they already implemented it, but this is like the deep dive. What happens? I mean, if you're working as a database administrator, you probably will have to take care of this, because you will have deadlocks, will happen, like weird things, because there's so many users at the same time, and you will have to resolve them. And then even though it is already made for small scales, probably there won't be any problems, but when it becomes a very large scale, you will probably have to work with this, and you need to have like a deeper knowledge of how these things work. But this is like already implemented in the DBMS. If you ask what DBMS is, yeah, you know what a DBMS is. Yeah, this is the internals of a DBMS. Yes. I mean, just math. Like just precedence graphs and how to take care of them. And a serial equivalent. Yeah, this is just a math. You learn this like in algorithms. Topological ordering is when you don't have any cycles and you order. So you just need to have a like when you have a precedence graph, then for example, you see T2 needs T1 and T3 to finish to release their locks. but that's like finishings. But the release that locks is more precise. So who comes first? Well, T1 has no dependencies in any RLL, so you have T1 first, and then T3 finishes, and then next you have T2. And then this is literally like, if you go in math and you learn DAGs, this is like literally the topological ordering of DAGs. And this assures that you can run them, like in sense, you can run them in parallel, or you have this, it's called the serial equivalent because this is just serialized, so you first run T1, T3, T2. But yeah, it's just math. And you can order them differently when you have like this protocol, that's what he's trying to say. Because you're locking like specific parts of T1, and depending how you log those specific parts, you can get different things. But I think here we just learned the most basic one, we just do a general thing and we just explain it generally, and this works. Which transactions are two-phase? Well, you can see this is a two-phase because you first log them all and then you unlog them. Yeah, this is the most important thing. Yeah, I mean, they call it differently here, but what you usually call is like a read lock, and then you have a write lock, and the write lock, that's your read too. I mean, it makes sense, a shared log, because reading, you can read the same book, all of you, no problem. But when you want to write at the same page or the same book, or you want to write something which is the same, then everyone needs to have his own parts where he writes it. Right, I write this sentence, you write that sentence. And then it's called exclusive because you only give it to one transaction. It's exclusive for that one transaction. I can say what are the types of locks. We have a textbook. I think... Let me... I think this one. Yep, this one. I mean, let me see the title so you can find it. Can I? Yep. Let me go to the beginning. Oh my god, the Obsidian is very weird with this one is called, yeah, Principles of Database and Knowledge-Based Systems. I mean, this is like this is even more math than this. When I really go like, it's just like it has even more math. We just learned several parts. Probably this, for example, object-oriented database languages, we don't need at all. This is nice, physical organization and transaction management. And I have distributed database management. Yeah, this is I think an exceptionally good book, because sometimes it's hard to understand because it explains it in such like math concepts and you're like, what is happening? But if you stick with it, I think you'll get far. Yeah. By the way, if you're wondering, I'm just making flashcards. So this is just I just make like questions, so I learn with flashcards. It's so much easier. You probably have used Anki, so I just do this, and then they're just export it to Anki. I just have them here and just learn them whenever I want. I can just study them, the questions. It's just I write them in Obsidian, and then there is like a plugin for Obsidian. You can Anki to Obsidian is a plugin, I think. You can use that plugin for both Anki and Obsidian, and then you can communicate like this. It just makes the flashcards for you. Sometimes it's weird. Doesn't work like it works fine, but I need to set it up. I just make questions, and then when I have time I just study them, like what is a transaction, what is compose, show, answer. Okay, I don't know, 1 minute again. I just repeat, because you need like spatial recognition to learn. But here right now I'm just writing the questions, and then when I have time, I don't know, when I'm in a metro or just staying, have nothing to do, I just open Anki in my phone and it's like, I just learn. But it's so important, it helps a lot, because when you make the questions, it's like, also making the questions is so important. Because you understand that you don't know something when you start making questions about it, and you don't even know how to ask. I find it useful. Probably there's other ways to learn. Yeah, it's also known as a read-only lock, yeah. It's interesting because the lock manager has only one key, and then that key can be shared, and it's called a shared lock. And then you have exclusive, you can read and write. So you don't have several things modifying the same data at the same time. Oh, items granularity. What it's saying, what granularity is, if you wonder, is like how large you choose the item. What do you lock? Do you lock the whole table, or do you lock a row? And then you're like, if I lock the rows, then I need to take care of which transaction do I give a lock to. And then you have like 1000 rows, and you have 1000 locks for each row, and it's like when the transaction request is for a row, it looks at the lock manager, and then he needs to look. The lock manager needs to look like for a big, too many locks, and you need to wait. But at the same time, if you lock a big table, so if you lock, for example, big tables, you have less locks, but still the level of parallelism is so much lower, because you're only locking the whole table. So, and when you lock the rows, so you have different transactions working at different rows, but when you lock the whole table, then there is just one transaction for the whole table, and there is less parallelism. So there is like a gain and effect in both ways. So you need to find how granular you want the data, how you want to cut it. You want to cut it with tables, you want to cut it with rows, you want to cut it with many rows, or how large you want the lock to correlate to, what's the size of data lock correlates to. And then you need to, and then this depends how many users you have in the database. And you see, this is not decided before, it's decided after. So that's what like a database administrator does, right? It needs to take care of this like small things. I mean, you can just be a normal database administrator and never care, but like for big databases, then I think it becomes really important, and you need to take care of. You need to tweak the database so you make it more perform better. Okay, let's see. What are they asking here? I mean, yeah. I mean, you can ask, I can just put this question and then just give no answer, or I can... I just write large, less overhead, but less parallelism, and then you have small, more overhead, more parallelism. And I written parallelism wrong. Let's go. Now how is parallelism written? It says Google, I guess. Parallelism. Yeah, but isn't it the same way? I just wrote it good right now. What did I write wrong in here? Oh, I wrote mine there. Yeah, update customers, and you have set the custom name, and you have Alfred, City, Frankfurt, where customer ID is 1. And then you have join, and you have an inner join between 2 tables. And you're like, if you have an inner join, then you need both tables to do the joins, right? So you lock the both tables. And then you're asking, okay, why don't I lock every time I do a join? So if you know, a join is like you have rows in a table, and you join them one by one. You join this one with this one, so you have a join condition, and you join them everyone with everyone, and then you get the second one and you join. And you can do, for example, row by row and lock the rows, but that doesn't make any sense because you wait, because you have so many rows in tables. To get the lock for that specific row, you need to wait a lot. So it's better to lock the whole table, the whole 2 tables, and do the inner join real quick and then finish with it. So it's better overall than just locking every row. So for this one, for the join, you know for sure you need to lock both tables, the customer ID and the orders and the customers. And then for example, for this, you update customers, you're only updating 1 row. So why do you need to hold why do you need to hold the whole table why do you hold the whole table? You can just hold this row real quick, and then everyone can work out in the table outside while you just work on your own row, so you don't mess up the others' work, you don't stall them down, and you get like more throughput. And your reality. Okay, rule of thumb. Proper choice for the size of an item such that the average transaction access fewest time. Yes. You measure this constantly in a database until you find, like, you tweak it until it's like pretty good. Assumption for simplicity, which will assume that the part of an item is modified, the whole item is modified. Yes, okay. Discuss. If a typical transaction in a relation system reads or modifies 1 tuple, okay, so if you ask what a tuple is, mathematically, in a sense, in our database, it's just a table. The table. It's just a row, I mean, what I'm saying. It's just the row is the tuple. A tuple is just in mathematical sense, you just put items into a tuple. So you can have, like, a tuple is a set of items, different type of items. And order, I don't know if it is order of an order. I think it is an order, but you may search it. But that's not the point here. In our case, it's just the row is the tuple. But just a mathematical definition is like this. So reads and modifies 1 tuple, which finds it via an index, but would be the proper item. The proper item for what? Is a row is the proper item. If a typical transaction takes a join or 2 or more relation for, yeah, it's what we speak now, right? Is you choose the table as an item. Conclusion: to achieve more concurrency while guaranteeing correctness, what must be done? To achieve more concurrency while guaranteeing correctness, every schedule of every collection of transactions is allowed if its effects happens to be equivalent to some serial schedule and forbidden otherwise. Yes, exactly. You just wanna make sure that nothing weird happens. So you just have you try to make it a serial schedule. You try to make it look that like they are executing one after each other, when in real life they're just executing in parallel. Is abort desirable? So when the deadlock happens, you usually abort, and then you're asking, do you want to abort, or how is the point with abort? Oh, you asked previously, do you use textbooks in your studying, not just DBMS? Oh well, it's usually we just have a lecture notes because like our professors are very specialized in their field, so they have like they own their own things, so they don't really like the books for some reason. Forcing many. So is the board desirable or not? Why? I don't know. Let's think first without reading. Do you want to abort? No, because if you abort the transaction, so if you say no to the transaction, then you need to care, you know, the dependencies. If you abort it, for example, you had this one, you were doing it, and then you T3, T2, and then you abort T1, and T1 changed something, then T2 and T3 then did change it, and then T3 and T2 used it, and then if you abort T1, what happens to T3 and T2? Should you also abort them because they're using data which was changed by T1? Yes. So aborting is not really desirable because you get how to say, you get a chain of reaction when you abort one transaction, and you need to abort many, and it's like so connected. So it's pretty bad to abort in a sense, but sometimes it's good. But let's see what they say. Forcing many transactions to wait for a long period may cause too many locks. Yeah, exactly. Waiting transaction might already have some locks. Deadlock causes many transactions to delay so long that the effect becomes noticeable for a user. Example, user standing at him. Yes. When deadlocks are inevitable, the scheduler has no choice but to abort at least one of the transactions involved in a deadlock. Yeah, when you have a deadlock, you should abort, and you need that. Oh, and then we have a state of a transaction. We just have a small state machine, I think. If any of the checks made by the database recovery fails, then the transaction is said to be in a fail state. Yes. So what are the states of the transactions? What are the possible states of a transaction? What are the possible states of a transaction? Failed state. I mean, I can just draw a diagram at the end so you have it like this. If any of the checks made by the database recovery system, Example, total mark calculation. Can you explain how this may apply? No idea. A fail state. It just be active and we fail. It can be partially committed and fail. I mean, this is pretty cool. Fail is when something wrong happened, but specifically it says if any of the checks made by the database recovery system fail. So you can ask a question, when does a transaction fail? Transaction fail. If any of the checks made. If checks made by database recovery system fail. Then the transaction is said to be in a failed state. Example, total mark calculation. What do you mean? Can explain how this might apply? I actually have no idea. I don't know. You're calculating the mark, and someone changes the mark, and your calculation then is wrong. During your calculation, someone say you like have marks, and then the mark was changed. So you started calculating the first guy, second, third, and then for the first guy the mark changed, and then your calculation is completely wrong. But I have no idea how this system can check it though. But okay, let's suppose it's there for right now. Maybe We learned it. Abort it. Restart the transaction, kill the transaction. So after aborting the transaction, after aborting the transaction, what are the possibles? I mean, this is obvious. Why do I write this? I just write it. I don't know. You can either restart, or you can kill the whole operation. This is just... Sometimes my questions are so weird. So what are the possible states of transaction? Well, I'm just gonna put this picture at the end as active state. You're just doing the transaction. So what is the difference between partially committed? What is the difference between partially committed and I know, I probably pushed my keyboard so far away. Oh, it was here. It's okay. So it's partially committed. It's two T's. Okay. And committed state. Two T's. Partially committed. The transaction finished the final step, but the results are not stored in the database yet. And then committed, is it saved? It is saved in a database. Permanently. I like that word. Permanently. Probably wrote it wrong. Permanently saved in the DB. Yes, and we just yep. And and second lecture. I think, is there a third one? I don't think so, right? Oh, there is a third lecture. Oh, the third lecture is the annoying one. I mean, yeah. We have things to learn, so we're right here. Oh, yeah, there's a lot of things in here. Like, I already have like the X. It's already 25 questions. Okay, we have. I just have a small break, I guess. I don't know. Is anyone watching? How do I watch how many viewers I have? Let's see. Let's see what's happening. It's me and me, probably. One watching, let's go. Whoever watched it, thank you, I guess. Oh, I got 3 likes. That's nice. I sound very weird, like, where is my enthusiasm, bro? It's like, oh my god. I probably will make like coding, probably coding will be more interesting, right? How do I sound? I sound very weird, like, where is my... Exactly. Like, oh my god. I want to see how... But you may search it. But that's not the point here. In our case, it's just the row is the tuple. But just a mathematical definition is like this. So, reads and modifies one tuple, which finds it via index, but would be the proper item. Yeah, let's go. I mean, it's, I don't know, first stream, I guess. I'm just going to have a break right now, so I don't know, just put Obsidian right here, maybe, for entertainment. And just... been 3 hours maybe, that's fine. But I'm just gonna be back. I just think we're gonna study like till 11 and then we go. Because I mean it's becoming too late, but let's just go. Read log model, yes, compatibility matrix. I mean I can do draw the compatibility. Oh my gosh. I'm getting tired. When I do this mistakes, it's because matrix. It's the most scuffed drawing I've seen all of this. It's okay. Read write lock, read lock, write lock. Okay, less restrictive. Block management and higher performance. Yes. And what's now we're using read write. Till now we just use locks generally, and now we're dividing our locks. Yes, we wait in here, but you can read in here. Yeah, it's just like while you see when you divide them into read and write, it's so much better because you see you wait a lot in here, but while you're reading this you can also read the same book, right? Reading the same thing, which is not changing, it's pretty easy, so you just read this and read this at the same time, so there is no problem with locking. So you can read the same thing I was trying to say, so you differentiate the lock, so you make that possible. You see, you can yes, read and write, This is like the dependencies. You write after you write, then you should wait. You read after someone else writes, you should wait. And we have read and write precedence graph. Yeah, so you have writing this, so you have read after write, so you should wait. So our T1 depends on T1, but T3 is read after read, doesn't depend on T2, but T3 depends on T1, so T2 depends on T1 and T3 depends on T1, and you have this precedence graph. Well, let's analyze this other one. You have read and write precedence graph. So you have T1, T2, T3, and you have you're locking A, unlocking A, you're locking you're reading after reading, so it doesn't matter, but you have a write after read, so this should happen after the reads. So you have T1 depends on T2 and T3. What? T2 depends on T... Yeah, T1 is depending on T3 and T2. If there is no directed site and our schedule is realizement, it has equivalent schedule, read and log, so order is irrelevant since it does not affect the data itself and no changes coming to the data. Remark, there is no edges because it doesn't matter if you have a read and read, this is because of this. Yeah, unlock is the source of the error and read write is the process destination of the error in the graph. Precedence graph, yeah, W lock. R lock. Yes, this is where a lock is behind, lock is up front, and then you have a read after read. So you have read after read, write after read, and you have a read after write and write after read. So we have locks in hierarchical structure. So the hierarchical structure, for example, a row is a part of the table, and now how do we take care of this hierarchical structure? This was nothing new, all of this is just wasting time, I guess. Hierarchical structure, so we have the locks in hierarchical structure. We have a tree protocol, rules we must follow. First lock can be put to any single node. Further locks must be children of a locked node. One node cannot be relocked. Each node can be only locked one. Okay, tree protocol. You are only allowed to access the locked node. In tree protocol, node deadlocks occur. Tree protocol produces realizable schedule. Okay. You are only allowed to access the locked node. So you have a locked node, and the node deadlocks occur. Why do node deadlocks occur? Yeah, because if you only lock the warning protocol, deadlocks can occur, but in a tree protocol, deadlocks cannot occur. Why cannot deadlocks occur in a tree protocol? Let me search the tree protocol. I don't know. Why is there no deadlock though? Oh, there is no deadlock because there is an order of locking. That's why. That's cool. I see. Because you know when I talked here, if you remember, I was talking about how to. Yep, here. How to have a solution to deadlocks. Recase all locks at once, so 2PL, or you can have a arbitrary linear ordering to all locks, and if you order them linearly like this, which the 3 protocol does, then you don't have deadlocks. I have a warning protocol. So location should be no. Do all. Oh. I mean, copy paste the rules. I mean, first lock everywhere. Children must be children. Children. What? I think I'm so tired of locked node. So children of locked node, only node cannot be relocked. So explain the 3 protocol and you have a children of a locked node. Children of a locked node, and then further lock children of a locked node, and then no relocking. Idea linear ordering of linear ordering of the locks. Which implies no deadlocks. Locks on hierarchical structure warning protocol. I just give more space to this, I guess. Yep. And then you have a warning protocol. So 2 warnings are good, but locking is not good. Explain the warning protocol. Explain the warning protocol. goes to PL. Sort of like the rules. Because if you put on locks, then it messes it up. Use and warn the locks. Locking a node is access to a whole subtree. Yep. So you warn this, and you lock, and you have this, or you can warn and lock each individually, but you can have a deadlock in here. It warns, and then it locks. With timestamps protocol. This is a different protocol. What are timestamps? What are timestamps in the timestamps protocol? Unique identifiers, that indicate relative starting time of a transaction. So there is a unique identifier for each transaction, and then at each data item, using timestamps protocol. What should be stored at the data item? Should allocate the data. Oh, this one is so good. Pam pam. Yeah, ta-na-na-na. Yeah, this one is great. I'm just enjoying music right now. I'm not even learning. I mean, right times. Oh, let me enjoy this one. This is a masterpiece. Nah, this one is such a masterpiece. Pam 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 pam. I'm trying to understand this. There is not much left, I guess, but not today. And today we're gonna have a break. I mean, this is not hard. It's saying if RA and WA are less than the time of TE, then if you read after that, then it's okay, because it doesn't matter. You finish your writing and reading, and if you read after that and write, it's okay. But if you have a transaction, which is it wrote before and then it read after, and during that time our transaction was reading, then it's okay. But during that time, if our transaction wrote something, then no, because when this transaction reads the other one, you're like, what is happening? And then you have both are greater than T, then you're reading, but then it's just written. So you're like, who wrote that? And then if you write, this guy reads and it says who wrote that, so it doesn't work. And then you have value does not exist. Okay. Read, but it doesn't exist. Okay. Yeah, you have here you have a lost update, because your update was lost. Because your update was lost. This is so weird, because what do you mean by this? It's okay. So the third lecture, I'll just learn it tomorrow, because right now we learned enough. So I don't know, end of stream. Do I do a clap? And it's done. Okay, love you guys. Good night everyone, and good dreams. Have amazing dreams. Stop streaming.